Well, it is finally time to get these wheel motor mounts bolted onto the vehicle and finish all the axle work on the other side of the rig. Welcome back, everyone. My name's Cole and we're getting back to working on this Snowcat today. In the previous videos, you've seen me really working on track grousers and getting all the tracks assembled. And that has been a massive labor of love. We went into full production mode. Go check out some of those videos if you haven't seen them. It was a pretty neat process. We had to make 132 grousers. Each grouser was made up of 7 pieces of metal that had to be cut or formed in some manner. I can't help but feel now I did it the hard way, but it should be a pretty cool product, and those are off getting hot dip galvanized. And I think they'll stay looking good for a really long time. If you're ever wondering why my shirt looks like this, it's from all the welding I do. You can see where my helmet is, and the UV rays just bleach out all my shirts. You know, I do have a leather jacket, but it often gets pretty hot, so I just like a light long sleeve. So with all those track parts off getting galvanized, it's time to turn our attention to the back end here, back to these wheel motors. They're a very large displacement. I think they're 350 cubic inch, fairly low RPM. They're meant to be a direct wheel motor. They have big taper bearings inside of them. They can take like a 5,000 pound load perpendicular to the shaft. So they are a perfect choice for directly driving our big sprocket on the back end here. And we did go ahead and make up these mounts quite a long time ago, but it's finally time to get them drilled and bolted to the rig. There is jack bolts, you'll see it when we're looking at the mounts a little closer, in the back here that allow this to slide forward and back. And that is our main track tensioning. This motor I put in just to get some idea of hydraulic lines and see where we're gonna be for our drive sprocket. But I think I'm gonna go ahead. I really don't like the idea of these lines coming off the backside where they can hit things in the bush, rock stumps, trees, whatever. I do think we eventually should have a guard over it, but I wanna go ahead and roll this motor to the top side so that the fittings can come up and then go in through some bulkhead fittings we're gonna wind up making for the hydraulic system. Before I really got into all the track fabricating, I went ahead and we put all of the stub axles into the vehicle. We went ahead, greased all the bearings, installed the seals so that I could get one full set of tires on. I did that off camera kind of. I mean, I did video it a little bit, but I've never really shown that. So today, we need to go ahead and we need to get this other side done. We'll get this girl back on her feet and we'll get the wheel motors on, through bolted, full adjustment. That's gonna let me have a little bit better idea of the length of hydraulic lines I need to order. We're getting really close. I have all the fittings now, or most of them. And lately I've just been trying to catch up on all the items I need to order to keep work going. I got so focused on that track building, it took months. I wasn't able to work on the actual CAT itself. So I've got a lot of stuff on order for the hydraulic tank. You know, we need filters, a housing, a filler cap, a vent. We need to make a bunch of NPT threaded bosses to put all the fittings in on the actual hydraulic tank. And then once we are close, we can then order our lines. I just want to make sure everything's going to interact well before we go ahead and spend the money on the lines. And I can have them made up locally in a pretty short notice. So we're getting very close there. Some other things I've been working on kind of in the background that's really hard to show much videoing on is my sprocket design. And I finally gone ahead, and I know it's pink, but it's one of the only ways I get to use up some of the plastic filaments that I never ever use. Because my printer can only print a 12-inch square area, these sprockets are almost 19 from tip of tooth to tip of tooth, 19.5 inches. So I split everything into a quarter. And we right now have the last quarter on the printer here, as you might be able to see right there. I know this looks kind of goofy. We're gonna super glue in the other part of this when it's done. This has nothing to do with the final use product. It's just a really simple way for me to double check my sprocket design. I did all the CAD work myself. There is nothing about this that isn't 100% custom. So we'll check the engagement on the grousers once the track is assembled, and then we're gonna go ahead and create a negative mold of this. And this is not the width of the sprocket. We're gonna be going 2.5 inches. This is only 1 inch. There was no point printing 2.5 inches just as a double check. And there is also going to be a shoulder on the inside, so it'll kind of fit like a spigot fitting. On the wheel motors, we're gonna have a circular faceplate that goes to a round tube that sleeves onto the wheel motor with a keyway. That will be welded, so it'll just be a big circular disc. We'll machine that really nice and flat and true. And then the sprocket is going to shoulder onto that and then have a bunch of 1/4 inch or 5/16 bolts. And that's gonna be our drive system. So I'm really excited for that. I can't wait to finally get this last piece printed. It's 7, almost 8 hours to print 1/4 of this. I'm printing it on a fairly high resolution because I just want a really nice quality part. All right, I know I've been doing a lot of talking, but I just want to explain all my thought processes here. Some people really enjoy how I get to explain all the details, so I'm gonna go ahead and do it. These were the previous sleeves that I made up. They're not gonna work. I actually need them a bit longer because I've changed my idea over time. I need the center of the sprocket to line up with the center of the tire, which isn't too hard of a thing to do. The faceplate itself the outside of it is gonna line up right with the center of the drivetrain, and the face on the spigot will also be that. So when they made up, everything centers really well. And I think it's 12 something inches from here, and this is only like, I don't know, 10. So we need to make a sleeve, and this sleeve gets keyed onto the motor shaft that will stick out a bit farther. A faceplate will have a hole machined into it. That'll get completely welded and then just faced off so it's nice and true. And then what we'll do is we'll machine a plug shim, and that will allow us to adjust the sprocket in and out. And you know, once we get it dialed in, we'll never really have to address that again. And we don't have to be super accurate. If it's within a 1/16 or an 1/8, that's gonna be fine. The sprocket's gonna be made out of a polyurethane, a 65D tough cast material. It's a really super strong resin, very durable. So there's gonna be no issues there. It'll just wear in how it wants to be. Tracking of the sprocket is gonna be allowed by our 2 jack bolts in the mount, and that can allow the wheel motor assembly to go either way to help track it, not to mention allow it to slide forwards and back to tension the track. And that's pretty much our drive system. I really can't wait to get pouring these sprockets and printing all the molds. I think it's gonna be a really interesting process, but I have to hold off on that until I check my test sprocket. Okay, with all that talking done, let's go ahead, take these wheel motor mounts off, or take the wheel motor off the mount, and we're gonna get all the holes drilled onto the rig itself, and we should be able to make up some stainless jack bolts. And then let's go ahead and get all the axles done on the other side, put this thing back down on its feet, and that probably will wrap up the video. But anyways, let's get to her. That's a pretty snug fit, which is perfect. Okay, let's go get these marked out on the rig. Feel like it would have been smarter to have these holes drilled before I welded everything on, but just didn't know what I was doing back then. I know folks are often worried about galvanic corrosion between the aluminum and the steel, and you know, they're right, it can happen, but you need it bare aluminum, bare steel, and an electrolyte like a salt water or something. Even something as simple as a coat of paint can stop that reaction from happening fairly easily. And when these go on for the last time, I'm gonna put like a really thick bushing grease in between there as well, so that grease will seal it all off, and I really don't feel corrosion's gonna be that big of a deal. And the same thing goes for these axles. When the stub axle shafts go into their tube, I coat them in anti-seize, and they're also painted, so corrosion between steel and aluminum just shouldn't be a big deal. For now, I'm just going ahead and using regular nuts, but when it's all said and done, we'll use nylock for sure. Right, you can see our jack bolt locations, and the idea is when the wheel motor's in here, you can jack them out evenly and it'll slide the bracket. Back these off a little bit. Okay, it'll slide the bracket forward and back, or you can tweak them a little to adjust tracking. I think it's gonna work out pretty good. And if you need to adjust any more than that, we can do a little fine tuning with the front tire pressure. And if you need more than that, you just gotta take another link out of the chain, you know? Okay, well, we have these wheel motors off the actual mounts. Let's go ahead. We got some stainless threaded rod. We'll TIG weld a nut on the end, washer, and a jam nut. And that's pretty much our jack bolts. And since we need 4 of these, let's go ahead and put the stopper on. All right, I gotta clean this saw up one day here. Okay, we're gonna go ahead, we'll take these jack bolts, put them in the lathe, just clean up the ends, put a little chamfer on them, and then on the end that's actually engaging with the Snowcat frame, we'll just put an ever so slight taper to keep the jack bolt from wanting to wander around as we do tensioning. Okay, with our jack bolts all nicely cleaned up on the lathe, we're just gonna go ahead, take a stainless nut, TIG weld the head on, and that turns it into a nice little bolt. And then we can put our jam nut on, thread it on into the motor mount. So that'll be it. That's all it takes. Okay, let's do some DC TIGging. There we go. Let's make sure I don't weld them on the wrong end. That would be something I'd do. start taking care of these axles on the, I guess, driver's side. Yeah. All right, well, I figured I'd just check, you know, see what these look like. And in my infinite wisdom, I just made the wrong size jack bolts. Sweet. Apparently the plates that I drilled and tapped in here were for 1/2" 13, and grabbed my stainless threaded rod off the table here, and I guess it's 5/8. So I like the idea of using a more stout jack bolt anyways. The 1/2" with that much extension might deflect a little too easy. So it's really not a big deal. We just gotta go ahead and drill out these jack bolt threads and tap it. But as I'm trying to scrounge around, I can't find a 5/8 tap here. Looks like I top out at 1/2" and then go to pipe thread stuff. So I guess I'm gonna have to wait to do that until I get the right tap, but that doesn't really matter. I mean, you get the idea. That's gonna thread in there and move the plate on the rig. Anyways, let's switch gears, get these axles on. So I went ahead and packed all these bearings when I did the first side using just a little bearing packer there. Didn't feel like doing it the old fashioned hand method, but in my, again, infinite wisdom, I've left these uncovered in this shop for a while, and there's little chips of metal and dust. So I'm gonna go ahead and wipe all of this grease that isn't packed into the races off, and we'll put a little new coating of grease on there. These are just, I think they're 1,200 pound rated stub axles for a trailer. I went ahead, taped off the races, and put a bunch of coats of paint on there. All right. Me and grease. It's almost as funny as me and anti-seize, because that stuff gets everywhere. Why am I doing this now? I should really finish up what I'm doing over here. So these two are ready for their seals. So the inward bearing gets completely put together with the seal stamped in, and then it goes in on the stub axle shaft, and then you put in the outer bearing, put your washer, your castle nut, and just not really preload, but just kind of hand tight so it spins, and put your cotter pin through, as you're gonna see. Right. Okay, let's flip all these over. I am loading these up with grease. Not because I really have to, but I don't want to have a problem. Doesn't really need the grease here, but I like filling it in anyways. I know it just makes for a bigger mess when you gotta take it apart. All right. There we go. We just got to make sure that that cotter pin isn't going to rub on the dust cap. All right, well, it's time to start getting these stub axles on the machine. A little bit of paint came off there, but I'm coating these with anti-seize, so I really don't think any kind of corrosion is going to be a problem. It'll be a miracle if I don't have this all over me when we're done. There. A little update for you. If you're not used to 3D printing, it doesn't infill. I selected a square pattern or rectangular, and right now it's laying it down in 0.02 millimeter layers. I know that lots of people think that these tires won't hold up, and they might not. I'm not saying for sure they will, but I think they're gonna surprise people. This machine is a lot lighter than bigger cats, and these tires can take a heck of a beating. I'm also running tubes inside them, so you know, it'll be a bit of a learning curve. Changing these tires out for something different, like a good 8-inch wide quad tire or a trailer tire, isn't gonna be that difficult. These just provide me with a little bit more suspension in the vehicle, and I'm really curious if they work. Okay, well, before I put the last rear two tires on, I just gotta go ahead and get this wheel mount done. Well, there you have it. I think that's the first time I've had all the tires on and both wheel motors in. Looks really good. I can't wait to get these faceplates done and the sprockets poured. There we go. Just another thing off the list while we're waiting for those tracks to come back. But this gives me a good idea of the way the hydraulics are going to be routed. So let's go ahead, take a minute, and I'll explain here. The beauty of what I'm doing here is I don't need any hydraulic valving to do my skid steering. We're using a tandem piston pump with a manual displacement control. So by just moving these levers on the pumps, we can direct fluid really infinitely forward or reverse. So that's going to make this vehicle a true zero turn, and it should pivot on its center axis in its own length, which I think would be really cool. Obviously very hard on the tracks, but if we're out on the ice, we could get this thing probably spinning right in a perfect circle. So with that being said, our hydraulics are actually relatively simple. We have an A and a B fitting, which is call it an inlet and outlet, but it really changes depending on what you're doing with the swash plate. Those lines have to come out, exit through the vehicle here, and for that, in a future video, we're going to take this aluminum round stock board out, put an NPT thread in it for a NPT to JIC fitting, and those are going to go through the hull. These will be like a bulkhead fitting sort of, but it's actually going to get welded into the vehicle. There'll be a fitting on the inside and a fitting on the outside. And that's how we're going to maintain the water tightness of the vehicle and transfer hydraulic fluid from the pumps down to the motors. So as I said, there's going to be a threaded bushing that comes out, I don't know, something maybe up here. I haven't exactly decided yet. I guess it'll go this way. And the hoses are gonna come around down to here. Now, obviously, I may have to set this inside a little bit because the track is so wide, and then we'll put a guard plate around that. I was thinking about coming down through here, but it makes for such a small hydraulic line, you'd never do it. And this does need to move, so I actually need to stretch these lines out. Maybe they even need to come back to here, up here, and make them longer so that I can route them flush with the vehicle down into the motor. Unfortunately, I've given myself a fairly tight area to work with these lines, but I think it's gonna work out pretty good. I'm just gonna avoid them from, you know, areas of problem, like in the rear of the vehicle. As I mentioned, I don't want rocks or sticks and stuff to hit these and break a line or whatever. And we can easily put a little bit of guarding over it too. So those are the things I got to figure out in future videos, and I was going to go ahead and buy all my lines, but they weren't able to make them, and it turns out it's pretty good because I do need to give this a little more thought. So, and then the other things to go with the hydraulic system are going to be a bit of a reservoir tank, either here or here. I haven't decided yet. The motor, the pumps themselves use a ORB fitting, an O-ring Boss, a -8. My motors have a 3/4 pipe thread NPT, and I'm going all to a 37-degree JIC, 5/8 lines. I did the math, and I think that we can get away with the flow rates, and 5/8 will be plenty. But that's all stuff to come in future videos. So that's actually a good little day's work. It has been months since I've actually worked on the rig itself and not on some component of the tracks, either making the dies, the grousers, stamping, belting, whatever. So it actually felt good to work on the rig itself because it has been a while. And we're pretty much all ready to go. So as soon as those grousers get back from galvanizing, we're gonna do a bunch of track assembly. I'm gonna be able to finalize my sprocket design. We're gonna go ahead and start 3D printing the molds. We're gonna pour it with polyurethane, a 65D, a Shore 65D. And I think it's been really awesome because we're going right from CAD design, 3D printed molds, pouring polyurethane into an actual finish use part. I don't know, that excites me. I've never done it before. I'm really curious to see how it turns out. I'm also not all that experienced with hydraulics. I've done a lot of learning, but there probably are better ways to do what I'm doing. That's fine. I'm gonna make it work one way or another. So I think I'm gonna leave that here. Thanks so much for watching another Snowcat video. There is so many cool things to come, as I've clearly rambled on about. And yeah, we'll see you in the next one. Cheers.